Today we're going to look at Lesson 14, Evaluation of Algebraic Expressions. And the word there, evaluation, I guess I want to start with that. What's the difference between evaluate and solve? Because the directions are going to be telling us what we're dealing with. In the case of an evaluation, we have an expression. There is no equal sign. Here it just says x times y plus z. It's not an equation because there is no equal sign. Down here, our directions are solve. We solve equations using inverse operations like we've been doing. So this is an expression. We evaluate it. This is an equation. We solve it. So today we're evaluating algebraic expressions. So we're going to have something like this. We're going to have something like x, y plus z. These are called variables or unknowns. We use them all the time in algebra. They're letters that represent a value. And in today's lesson, they're going to give us the value. We just plug those values in, and then we evaluate. What is the expression equal with those assigned values? I don't know why they decided to call variables, use letters to represent them. I guess they could have said triangle, square, and rectangle, and they could have said triangle equals 1, circle equals 2, and rectangle equals 3. Would have worked the exact same way. It's just they decided to use letters, and I guess it seems to be a good method. But if we're going to evaluate this expression, then we would simply plug the values in. X equals 1, y equals 2. So we had x times y, so now we have 1 times 2. Z equals 3. Order of operations says multiply first, then add. So we have 2 plus 3 equals 5. We evaluated this expression, and the expression equals 5, which is different than solving, where we would use inverse operations to solve the equation. Here are two more examples where we're evaluating. Again, not solving, we're evaluating this expression. The opposite of A minus B minus A times B. So the very first thing we do is we plug in the values. We know that A equals -3. So we have the opposite of -3 minus B equals -4, so minus -4 minus A times B. A is -3 and B is -4. So the very first thing we do is write the values in. And don't be confused by these opposite symbols or these negative symbols. Ask yourself, what is A? A is -3. So the opposite of -3 looks like this. And once we plug these values in, we have to now consider order of operations. Really what we have is the opposite of -3 minus -4 minus -3 times -4. Order of operations says we do this first. Multiplication comes before addition and subtraction, so we're going to rewrite. And then we simplify this to 12. Now we work left to right. One thing I can do is say, well, the opposite of -3 is +3. Minus -4 is the same as adding 4. Subtracting -4 is the same as adding 4. And then finally, -12. Left to right again, since addition and subtraction are on the same level in order of operations. 3 plus 4 is 7. Minus 12 is -5. So this entire expression equals -5. Alright, we'll do one more here. First step, plug the values in. X equals 2. So you have -2, or the opposite of 2, minus the opposite of A. A is -4. I'm going to rewrite that since it looks like a 9. Plus b equals negative 6. Sometimes we kind of like to, I like to, if we have parentheses like this right next to each other, it's a little easier for me to follow personally if we make the parentheses a different shape. Otherwise it sometimes gets confusing if they look the same. Nonetheless, we have to take negative 2 minus this whole quantity. To find out this whole quantity, we work our way inside out. We've got negative 2 minus. The opposite of negative 4 is positive 4. And then plus negative 6 is the same as minus 6. So negative 2 minus this equals negative 2. Positive 4 minus 6 is negative 2. So negative 2 minus the opposite of 2 is the same thing as negative 2 plus 2. So this entire expression simplifies to 0. So plug those values in, and then remember here we're evaluating algebraic expressions. These are algebraic expressions. Algebra deals a lot with variables or unknowns, values. Sometimes we solve for them when we have equations, and sometimes we just simply have to evaluate when they give us the values. We're going to do one more example here. A little more complicated, but really what we have is we're going to multiply these two quantities together, and whatever that equals, we take the opposite of that. We're evaluating an expression with 3 unknowns or 3 variables. In this case, they are m, x, and a, and they give us the values. So I'm going to start by just plugging them in. The opposite of m is 2, plus x is negative 3. Again, this might be a case where I'm actually going to change the look of that other parenthesis over here. Once I plug in, it's just going to help keep that organized in my mind. Do the same thing over here. A is negative 4. That's a 4. I'm going to back that up just to make sure I don't confuse myself later. Plus m is 2. X is negative 3. And there we have it rewritten. So still multiplying these two quantities together, taking the opposite. I can simplify this guy without breaking any order of operation rules right away. I'm going to simplify him to 2 plus negative 3 is the same as 2 minus 3. So this equals negative 1. And then over here, this is positive 4. A lot of times we don't write that positive, but I'm going to write it anyway. Plus 2 times negative 3 is negative 6. So the opposite of negative 1 times positive 4 plus negative 6 is the same thing as 4 minus 6. Positive 4 plus negative 6 is the same thing as 4 minus 6. That equals negative 2. So in here we have negative 2. So really this is like multiplying by a negative 1, but we'll just do our multiplication here. This equals negative 1 times negative 2, positive 2. If we multiply that out, so really what we have is the opposite of 2, or negative 2. So that whole expression, when evaluated, simplifies to negative